Hi everyone. How do you graph y equals x to the 2/3? Well, how can you write that in radical form? How could you write x to the 2/3 in radical form? You could write it as the cube root of x squared. What is the domain of this function? Well, you can take the square of any real number and get a real result. You can take the cube root of any real number. So domain is all reals. Is it even or odd? Well, if we substitute x with its opposite, the square doesn't care about this -1 factor. We end up with the same result. So it's even. Domain is all reals, and it's an even function. What does this look like? In quadrant 1, we get a hook, kind of like the square root or cube root, but it's an even function. Symmetry about the y-axis. This is like a bird beak, a funnel, or tornado. And this point at the origin is called a cusp. This is the nicest graph where we get a cusp in calculus, where we have continuity, and we have infinite steepness from both sides, but in opposite ways. A cusp. Many graphing calculators have a hard time doing this. Desmos can do it. Y equals x to the 2/3. Okay. In general, if you have x to a proper fraction, even over odd, you get a bird beak like the above, like x to the 2/5 or x to the 4/7. What about absolute value? Now, actually, this is an algebraic function because you can think of the absolute value of x as the square root of x squared. But here's the piecewise definition. We have basically y equals x if x is non-negative, and y equals the opposite of x if x is negative. How do you graph these? Well, it's a piecewise graph. You get the piece of y equals x here, so you get a piece of this line here, and you get a piece of y equals the opposite of x with slope -1. You get a piece of these two lines, and they come together at the origin. Here's y equals x over here. Here's y equals the opposite of x over here. Even, odd, or neither. Symmetry about the y-axis, it's even. Also, remember, the absolute value of opposites are equal. Domain is all reals. That's the V-graph, the V-graph. And this is called a corner, not a cusp, because you don't get infinite steepness. Upper semicircles. Remember when you took this equation, solved for y, took the non-negative root, y equals root 9 minus x squared. Remember, y equals square root of 9 minus x squared. That was the upper half of a circle of radius 3, centered at the origin. In general, if you have y equals the square root of a squared minus x squared, where a is positive, you get an upper semicircle of radius a, the upper half of a circle centered at the origin. Remember this form. Look over the gallery of graphs. It's a summary of what we just did. Be able to graph all these basic functions. And then you want to have to point plot all over the place. We can fall back on these. In section 1.4, we're going to manipulate and transform these.